Hey everyone, welcome back to the channel. If you're new here, I'm Ryan, a Cambridge Mathematician, and I also used to mark the STEP Maths papers, which is the entry level for Cambridge Mathematics. So today I wanted to go through a TMUA paper. So TMUA stands for Test of Mathematics for University Admission. So this is a paper that's used for the likes of Cambridge, Imperial, Warwick and Durham, and it's one that tests your mathematical ability. It's used outside of maths as well, so computer science, economics might ask for it. And today I just wanted to sit a paper, show you how I would attempt the paper. I've not seen it before, so this will be brand new to me. You can see how I would attempt it, see where I struggle, see if you can take any tips that I've used and you can apply yourself. So I'll be sitting paper 1, which is the more A-level focused maths paper. I will have a part 2 to this where I sit paper 2, because that one is more proof based. So that's something new that you won't have seen before. So I'll be sitting that in a future video. But for today, I just wanted to attempt paper 1. And the one I'm going to be attempting is from 2022. Okay, so paper 1. There's 75 minutes for this. There's 20 questions. It's not a lot of time per question. And as I've said before, this is a very quick paper. You want to be acting quite speedily and going through the questions quite quickly. I'm going to be trying and talking through what I'm doing throughout, but it's quite hard to do while also doing the speed. So bear with me. If you've got any more questions, put them in the comments. I'll try and answer them. So let's get started. Okay, so we've got 2 cos to the power 4 minus 5 cos squared theta plus 3 equals 0. So that is, write this down, 2 cos to the 4 theta minus 5 cos squared theta plus 3 equals 0. This immediately to me looks like a hidden quadratic. So that's 2y squared minus 5y plus 3 equals 0. So that can be factorized to be 2y minus 1, oh no, to my minus 3, y minus 1, I think. Expand that out, 2y squared minus 2y minus 3y plus 3. Yeah, perfect. So we either have y equals 3 over 2 or y equals 1. Now, can't have y equals 3 over 2 because cos squared theta only goes between minus 1 and 1, so we can't have that. So we must have cos squared theta equals 1. So cos theta equals plus or minus 1. And if that's true, then we must have how many solutions? So we want between 0 and 2 pi. So we want here and here. So we have one solution down here, one here, one here. That's 3 solutions. So I would go with answer C. Okay. Question 1 done. Question 2, find the complete set of values of p for which the equation x squared minus 2px plus y squared minus 6y minus p squared plus 8p plus 9 equals 0. Okay, first thing here I'm going to do is try and get it in the form I know for first circles. So that's x minus p squared, and then I need to minus off p squared, plus y minus 3 squared minus 9, then add on all the rest. It should be minus p squared plus 8p plus 9 equals 0. That cancels with that, and yeah, that's all I'm left with. X minus p squared plus y minus 3 squared equals, take those to the side, 2p squared minus 8p. And what do we want? Describes a circle in the xy plane. So the only condition I know for a circle, this is fine, but this has to be positive or greater than 0. So therefore I need 2p squared minus 8p greater than 0. I can take out a factor of 2p. 2p, p minus 4 must be greater than 0. So therefore I have 2 solutions to that, which is p equals 0 and p equals 4. I always like to quickly sketch the quadratic. So I've got 2 solutions and the curve looks like this. So that's 0 and then that's 4. So I must need p, because I want to be above the curve, p less than 0 or p greater than 4. So that is D. Perfect. Glad there is an answer. Question 3. Given the following statements of the function f dash dash of x equals a. For all x, so that's a quadratic of some form, f of 0 equals 1, f of 1 equals 2, integral of f of x is 1. Okay, so it's just 3 conditions. It'll give me my 3 parts to my quadratic. So 3, f dash dash of x equals a means that f dash of x equals ax plus b, f f of x, integrate again, equals a half ax squared plus bx plus c. And what do I know? I know f of 0 equals 1. That means that c must equal 1, and then f of 1 equals 2 implies that a half a plus b plus 1 equals 2, so therefore a half a plus b equals 1. What do I want to eliminate? I want to eliminate b because I don't care too much about b because I only want a, so b equals 1 minus a half a. F of x equals a half ax squared plus 1 minus a half a times by x plus 1. And then integral of that between 0 and 1 dx equals the integral of a half ax squared plus 1 minus a half a x plus 1 dx between 0 and 1. This gives me 1/6 ax cubed plus a half 1 minus a half a x squared plus x between 0 and 1. Don't really care about the 0 because it's always going to be 0, so it's 1/6 a plus a half 1 minus a half a plus 1 equals 1. It's easy. The 1's cancel. I'm left with 1/6 a equals, 1/6 a minus a quarter, a equals a half. So that is 1/6 and a quarter, go to a 12, so that's 2, should be equal minus a half, minus 1/12, a equals minus a half, a equals 6. Okay, that's 3 done. 4. These sectors of circles are similar. Okay, the arc length of the smaller sector is 6. The difference between the areas of the sectors is 21. Find the positive difference between the perimeters of the sectors. Okay, so I just need to work out what that arc length is. So if they're similar, then the difference between the areas of the sectors is 21. So area of a sector is 4 half r squared theta. Theta is the same for both, but r is not the same for both. So then a half r plus 3 squared theta minus a half r squared theta must be equal to 21, I assume that one's bigger. So therefore, expanding that, a half r squared theta plus 6 divided by 2 is 3r theta plus 9 over 2 theta minus a half r squared theta must be equal to 21. They cancel. I'm left with 3r theta plus 9 over 2 theta equals 21. What do I want to work out? I want to know what r theta is, because that tells me my angle. And find the positive difference between the perimeters of the sectors. So perimeter of the sector is 2r plus 6 from the bigger shape, plus r plus 3 theta, minus 2r minus 6. Well, plus 6 in there. So then they cancel out, and I just need to work out what r plus 3 theta is. And can I work that out from here? So I know that 3r plus, not quite. So what do I need to do? So r plus 3 theta, and I know they're similar, but doesn't help me too much here. So does theta actually matter? So I've got 3r plus 9 over 2 is equal to 21 over theta. Therefore, 3r is equal to 21 over theta minus 9 over 2. R is equal to 7 over theta minus 3 over 2. I think this is going to make a difference. So then I've got 7 over theta minus 3 over 2. Minus 3 over 2. Plus 3 times by theta is equal to 7 minus plus 3 over 2 theta. Doesn't help me too much because I still don't know what theta is. Oh, but I do know that r times theta is equal to 6. So therefore, r times theta is equal to 6. So therefore, then 9 over 2 theta equals 21 minus 18. So 9 over 2 theta equals 3. Theta equals 6 over 9, which is 2/3. So this is equal to 7 plus 3 over 2 times by 2/3 equals 7 plus 1, 8. So I'm going to go with C. And on to 5. That one took me a bit more time than it should have. So on to 5. The terms xn of sequence follow the rule xn plus 1 equals xn plus p over xn plus q. Given that x1, find x4. Okay, so I'm just going to use the rules and I'll find what p and q are, and then, yeah, I can find the next one. So x1 equals 3, then x2 equals 3 plus p over 3 plus q. And I know that that is equal to 5. And then next one, I might actually expand that. So that's 3 plus p equals 15 plus 5q. I know that x3 is equal to 5 plus p over 5 plus q. That's equal to 7. So therefore 5 plus p is equal to 35 plus 7q. Call this one 1 and then this one 2. Then do 2 minus 1. That gives me 2 is equal to 20 plus 2q. So therefore 2q is equal to minus 18. Q equals minus 9. And then, how do I find p? P, 3 plus p equals 15 minus 45, so that's minus 30. P is equal to minus 33. Oof. Just double check that that works. So 3 minus 33 is minus 30. And Q minus 30 over minus 6. Yep, that works. So then x4 is equal to 7 minus 33 over 7 minus 9, which is equal to minus 26 over minus 2 equals 13. I'll go with H for that one. And then on to 6. So given that integral between log 2 of 5 and log 2 of 20 of x dx equals log 2 of m, what is the value of m? Okay, that doesn't look too bad. It just looks like a bit of logarithm work. So we've got the integral between log 2 of 5 and log 2 of 20 of x dx, which is easily integrated to be a half x squared between log 2 of 20 and log 2 of 5. So then that's equal to a half, and then I'll just do it as a big bracket, log 220 squared minus log 2 log 2 of 5 squared. Now, log 2 of 20 is the same as log 2 of 5 plus log 2 of 4. So that's log 2 of 5 plus log 2 of 4 squared minus log 2 of 5 squared is equal to a half. Log 2 of 4 is just 2. So then I've got log 2 of 5 squared plus 4 log 2 of 5 plus 4 minus log 2 of 5 all squared equal to, them two now cancel. And then I'm left with 2 plus 2 log 2 of 5. That's not how they wanted me to end it. So I've got to take the 2 in, which is equal to, so this I can turn back to what it was before, which is log 2 of 4 plus log 2 of 25, which is equal to log 2 of 100, which is an option, and that is F. Seven. Find the finite area enclosed by the line y equals 0 and the curve x squared minus mod 4x minus 12. So let's first sketch it. Y equals 0 is just the bottom. And then x squared minus 4x minus 12. So what does that look like? Where does that hit the axis is my first thought. So I'm going to do it into two cases. When x is greater than 0, we have x squared minus 4x minus 12 equals 0. Then x minus 6, x plus 2 equals 0. So I have one crossing point at x equals 6. Can't use the minus 2 because that's against what I said before. So I have one crossing point at x equals 6. And again, I have another one, x less than 0. I've got x squared plus 4x minus 12 equals 0, which will give me x minus 2, x plus 6. So I have x equals minus 6. So this is symmetric, which kind of now makes sense. Because if you think about everything there, x squared is even, mod x is even, and then constant's even. So it crosses there. And it's going to look something like this. It's going to be a bit jagged, but like something like this. So we want the area in between there. So I've got to split into two integrals. One when we're greater than 0, and one when we're less than 0. So going between minus 6 and 0 of x squared plus 4x minus 12 dx equals 1/3 x cubed plus 2x squared minus 12x between minus 6 and 0. It's equal to 636 times by 6 over 3, which is just 72. And it should be minus, because it's the second bracket, minus 72, and then 6. We're doing minus, so it should be negative 72 as well. Double negatives, be careful. Minus 72. 6 squared is 36, plus 72, so they cancel, perfect. And then, again, another 72, plus 72. Equals minus 72 from that one. But we're concerned about the area, so ends up being 72. And by symmetry, as I said before, this area must be the same as this area. So I'm going to double that and get 144. Makes it easier at the end. 144, which is option E. Question 8. A geometric sequence has first term A, common ratio R, where A and R are positive integers and R is greater than 1. Sum of the first n terms of the sequence is denoted by Sn. It's given that the terms of the sequence satisfy this. S30 minus S20 equals K S10. What's the smallest possible value of K? Okay, so Sn for any n is equal to A 1 minus r to the power n over 1 minus r. Again, we don't know what any of these are other than we will know n. So S30 is equal to A 1 minus r to the 30 for 1 minus r. S20 is equal to A 1 minus r to the 20 over 1 minus r. And we've got S10 is equal to A 1 minus r to the 10 all over 1 minus r. Okay, so S30 equals 30 minus S20 equals K times S10. So I'm going to eliminate all the denominators because they're definitely going to cancel, and all the A's as well. That makes it easier. 1 minus r to the 30 minus 1 minus r to the 20 equals K times 1 minus r to the 10. So I've got r to the 20 minus r to the 30 equals K minus K times r to the 10. And what is the first possible value where these can be equal? What value of K? And I don't know anything about, all I know that is that r is greater than 1. So just going to flip these over just to make it slightly easier for myself. R to the 30. Ooh, can I do something like that? It's r to the 20 plus K times r to the 10 minus K equals 0. Is this a hidden quadratic again, but a cubic this time? Still don't know anything about, so I'm wondering where these answers are coming from. But oh, okay, let me rearrange this slightly. Instead, go back and take out r to the 20. Then I've got 1 minus r to the 10 equals K 1 minus r to the 10. So I can cancel that with that because I know r has to be greater than 1. So r to the 20 equals K. But I don't know what... But how do I know what r is? Interesting, I don't know anything else. Sum of the first term n is Sn. Given that that is true, what is the smallest possible value of K? Oh, for any A and R. R is integer, it's greater than 1, so the smallest integer greater than 1 is 2. So it's got to be 2 to the 20. Yeah, so it's got to be 2 to the 20. That's awkwardly worded. So that would be B. My best guess for now. None of the others make sense. So 9. Got to move on. Can't spend too long on this. How long have I spent so far? 24 minutes. So I am ahead, but still. Question is about pairs of functions f and g that satisfy f of x minus g of x equals 2 sine x and f of g of cos squared x. Across all solutions for f of x, what is the maximum value that f of x attains for any x? Ooh, interesting. So let's see if I can rearrange for f of x in some way. F of x equals cos squared x over g of x, and then f of x minus cos squared, sorry, rearrange that the wrong way. Top one should have been g of x equals, I want to get rid of g of x, cos squared x over f of x equals 2 sine x. So then we're going to multiply everywhere by f of x, so f squared of x minus 2 sine x f of x equal minus cos squared x. Does this help me? Not sure it does. Okay, so let me expand this to be minus 1 minus sine squared x equals 0. And I know f of x has to be some form of a sine x. Otherwise it won't break down. Sorry, it will break down. So I've got f squared of x minus 2 sine x f of x plus sine squared of x minus 1 equals 0. Now my instinct is to say that f of x is sine squared of x, and then these will cancel, but then I'm going to end up with a minus 1. I'm going to leave 9. I'm not sure what to do for 9. I'm going to come back to it. Okay, so moving on to 10. Which of these translations is applied onto the graph y equals x cubed? Which of the following graphs could be a result of this sequence of translation? So, okay, so the x cubed graph is translated. Which one of these could it possibly be? Okay, so they all look kind of like expansions of like a translation to the right or left. So let me try. Can't see it immediately. So let's go with y of x minus 3, which is equal to x minus 3 cubed, to x cubed minus 3 times 3, so that would be minus 9x squared, not quite what I wanted, plus 27x, and then minus 27. Okay, yeah, that's not 1, but that is 2, because then it's just a shift upwards of 24, which you can do at the end, so that's vertically. Okay, so yeah, that's fine. So that's 2. So 1, I'm not sure. I don't think I can. Maybe x minus 3. No, I don't think. X minus 1 cubed? No, because that would give me plus 3x. So no. That one, yes. And 27x cubed minus 9x squared plus x minus 3. No, I don't think that one is. Again, I'm just guessing here, but for the sake of speed, I would go with C, which is 2 only. 11. Evaluate this, so adding all the logs together. So from n equals 1, which would be, okay, so I think this is doable. Log base 10 of z of 1 plus log base 10 of 3 plus dot 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 all the way up to log base 10 of 100 would be, oh wait, no, wait, well, wrong way. 3 to the minus 1, all the way up to 3 to the minus 99. Okay, so by logarithm rules, that's 0. Then I've got minus log base 10 of 3, minus 2 log base 10 of 3, plus dot 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 all the way to minus 99 log base 10 of 3. So the logs all add together because the powers came down. And so I'm literally just summing from, well, I put minus in front, from 1, from n from n equals 1 to 99. Yeah. Okay, so I can just use n over 2, 2a plus n minus 1d. I should have used a different letter, but never mind. So how many do I have? I have 99 over 2. I have 2a, which will be 2, plus n minus 1, which will be 98, times by d, which will be 1. Got 150 times 99, which is, oh god, 990 times by 5, which is going to be 4950, I assume, because I'm too lazy to work that out. It's going to be less than 5,000, so minus 4950, and that's log base 10 of 3. So that would put me at A as my answer to 11. So I'm going to go straight to 12. A family of quadratic curves is given by y, k equals 2, x minus k over 2 squared, plus k squared over 2, plus 4k plus 3, where k is any real number. All these curves are sketched, and the point with the lowest y coordinate among all of the curves yk is AB. Okay. So that's for any real, k is any real number, so not an integer. Okay, so I'm just essentially finding the minimum for any k of any curve. Okay, so that's easy. So lowest point y coordinate, so I'm just finding the minimum. So yk equals that, 2x minus k over 2 squared plus k squared over 2 plus 4k plus 3. Well, finding the minimum of this is generally quite easy because it's complete the square, so minimum is at x equals k over 2, and then that means that y equals, that cancels, so it's k squared over 2 plus 4k plus 3. And now instead of finding the minimum of x, I need to find the minimum of y, which again I could just complete the square for. Yeah, why not? Y min, I'll just call it min y equals half k squared plus 8k plus 6 is equal to a half k plus 4 squared minus 16 plus 6 is equal to a half k plus 4 squared minus 10. So minimum is at minus 5. But what do I need? A plus b, a plus b, a plus b. Well, so the minimum of k min equals minus 4. So this is b, and then a is equal to minus 2. So a plus b equals minus 7. So that is D. 13. Given that a cubed plus 2 over b cubed, 2 over a cubed minus b cubed is equal to the square root of 2, where a and b are real numbers, what's the least value of a, b? So a cubed, expanded, it should be expandable, so you've got 2 plus minus 2 from the other one. Oh, what is this going to be? I feel like I shouldn't expand, but minus a cubed b cubed plus 4 over a cubed b cubed equals root 2. So essentially this is just, this cancels with this, and I've got 4 over y cubed minus y cubed equals root 2. I'm then going to multiply both sides. 4 minus y to the 6 equals root 2 y cubed. And, oh, it's just hidden quadratic. Hopefully this works. 4 minus z squared equals root 2 z. So z squared plus root 2 z minus 4. I just need to be careful with that, equals 0. And then, can I do this easily? Z minus root 2. I was hoping this would be easy. 2 root 2 and root 2. 2 root 2 and root 2 multiplied to give me 4. So plus 2 root 2 and z minus root 2. So z equals 2 root 2. But that's ab cubed equals 2 root 2. And then, so now I need to work out what ab is. And, this is equal to 2 to the 3 over 2, so it's just 2 to the half. But could I have minus? I think I could have minus, because AB, no, I can't. But this should be minus. This should be minus, this should be minus, then this should be minus. So I'm getting minus root 2, which would be A. Immediately, 14. Circle has centre O and radius 6. P, Q and R are points on the circumference with angle POQ greater than or equal to pi over 2. The area of the triangle POQ is 9 over root 3. What's the greatest possible value of the area of the triangle PRQ? Okay, so I need to draw this. So O, centre on the origin, makes it easy, and radius 6. P, Q and R are points on the circumference where P or Q is greater than pi by 2, which is 90 degrees. So let's go P, and then let's go Q up here. Then that's POQ. And the area of POQ, I need R somewhere, but I haven't been told about R. On the circumference with angle POQ greater than... area of the triangle POQ is 9 root 3. What is the greatest possible area of the triangle PRQ? So R can be literally anywhere on that circumference. Okay, so the greatest possible, I know nothing about R though. All that tells me is something about P and Q and how their angles vary. Well, I know this is 6, 6, and then whatever the angle is in between by a half AB sine theta for any triangle is equal to 18 sine theta is equal to 9 over root 3, and then so therefore sine theta equals root 3 over 2, so therefore theta equals 60 degrees, but we know it can't be 60 degrees. They've told me it's greater than 60 degrees, so it must be by sine 180 minus 60, which is 120 degrees. 120 degrees. So this is 120. Cross this out. This is 120 degrees. Therefore, this is what's left. So it's 120 of 180, so there is 60 left, so 30 degrees. 30 degrees, does that help me? Not massively. How can I use that to help me with R? Because R doesn't necessarily need to be... It would tell me the length between those two, but then that's not enough for... Gonna skip, gonna come back. 15. Rectangle is drawn in the region enclosed by the curves P and Q, where P of x equals 8 minus 2x squared and Q of x equals x squared minus 2. Just the sides of the rectangle are parallel to the x and y axis. What's the maximum possible area of the rectangle? So we should draw this. 8 minus 2x squared equals 0. So you've got x squared equals 4, x equals plus or minus 2. So it looks like, and it also goes to 8. So it looks like this. So the sides are parallel to x and y axis, okay? And the curve x squared minus 2, so that goes through 1, goes through here. Okay, so likely well actually no, almost definitely, the sides are on here, 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 and here, but it's how we maximize that area. So likelihood is that we're going to have so for these two, the x values must be the same, and same here, and the y values must be the same for these two. Okay, but that makes it somewhat easy because I just need an equation for the area. So area equals the change in x, which will be 2 times whatever x I choose, and then the change in y, which will be the top one, which will be 8 minus 2x squared, minus the bottom one, which is x squared minus 2. So that is my equation for the area given just a random x value. So then that's equal to 2x, I'm going to keep it like that, 10 minus 3x squared. And now I want to maximize this area. So to maximize this area, differentiate d by dx equal to 10 minus 3x squared plus 2x minus 6x. Okay, so copying this and moving on to another page. Then I have 20 minus 6x squared and minus 12x squared, and that's equals 0 because I'm looking for a maximum. So then I have 20 minus 18x squared. It's not super nice, but none of the answers look nice. X squared equals 20 over 18. X equals, it's going to be positive because I only care about the positive one. And that is square root of 20 over 18, which is equal to square root of 10 over 9, which is square root of 10 over 3. Some of them have root 10s in there, that gives me confidence. And then area is equal to 2x 10 minus 3x squared. So that's 2 root 10 over 3 multiplied by 10 minus 3 times by 10 over 9, which is equal to 2 root 10 over 3 times by 10 minus 10 over 3, which is 20 over 3. So then that's 40 root 10 over 9, which is h. Perfect. I was not confident in that, so that's good. 16. Solutions to 7x to the 4 minus 6x squared plus 1 equals 0 are plus or minus cos theta and plus or minus cos beta. Which following equations has solution plus or minus sine theta and plus or minus sine beta? Okay. Interesting. So if x equals cos theta, plus or minus cos theta, and x equals plus or minus cos beta, then if I want the other one to have solutions to that, I need it to be, so I want it to use the identity equals x squared, then sine squared theta equals 1 minus x squared, sine theta equals square root of 1 minus x squared, and similarly sine beta equals square root of 1 minus x squared. Okay, that means I want to go back into that original equation and sub in 1 minus x squared, I think. So if y equals 7x to the 4 minus 6x squared plus 1, then I want to sub in y of 1 minus x squared. 7, well actually technically square root of 1 minus x squared, but it doesn't really matter for this. And so that will be 1 minus x squared squared minus 6, 1 minus x squared plus 1. That is 7, 1 minus 2x squared plus x to the 4 minus 6 plus 6x squared plus 1 equal to 7x to the 4 minus 14x squared plus 6x squared plus 7 minus 6 plus 1 equals 7x to the 4 minus 8x squared plus 8 minus 6 is plus 2. So that is 7x to the 4 minus 8x squared plus 2 is B. Perfect. Nice. 17. Okay, so find the complete set of values of x, which there are two non-congruent triangles. So if they're two non-congruent, that means they're not the same shape. So that means they must have different lengths, but one length has to be the same, it's the other length, so I just need a solution to that, right? Am I missing? Or so for me, this suggests that minus x squared plus 6x minus 5 must have two solutions, and I must also satisfy two solutions. And I must satisfy x must be greater than 1 and this, x must be greater than 1 and x must be greater than, this must be greater than 0. Okay, so minus b squared minus, sorry, not minus b squared minus 4ac. Oh no, because it's not that simple. Oh yeah, no, I want two solutions. Right? Wait, I'm confused. So I'm working out when I have two solutions, but do I always have two solutions? No, sometimes I have one solution. But for what values of x are there? Oh, it's the third side. Okay. So it's to do with the sine theta. Okay, so sine of this bottom angle, theta, 30 degrees, and so this is a given, and this is x minus 1. So sine 30 over x minus 1 equals sine of theta over minus x squared plus 6x minus 5. Sine 30 is a half, so I've got a half. Got a half over x minus 1 equals sine theta over minus x squared plus 6x minus 5. Oh god, I'm not entirely sure what I'm doing here. So sine theta equals a half minus x squared plus 6x minus 5 all over x minus 1. I think I'm getting somewhere. I'm hoping this should factorise. Then sine theta should equal a half, and then open bracket, this is minus x squared minus 6x plus 5 over x minus 1 equals a half minus x minus 5x minus 1 over x minus 1 equals a half, These cancel, minus x minus 5. So I've got minus a half x minus 5. Okay, so I need x to be, well, I need a solution to this first off, so that must mean x must be, oh, if it's between 1 and minus 1, do I get two solutions? In 1 and 0, I get two solutions, so x, right, even, minus 30 would be, yeah, it needs to be between 0 and 1. So I need, it must be less than 5. Must be less than 5. But it must also be bigger than, if x is too small, then it can't be bigger than 2, so 3. So I'll go with E. 18. It is given that f of x equals x squared, x minus 1 squared, x minus 2, so that's a quintic. And g of x equals p, x minus q squared, x minus r squared, okay, where p and q and r are positive and q is less than r. And a set of values for q and r that guarantees the greatest number of distinct real solutions of the equations f of x equals g of x for all p. P is positive, that's good to know. Okay, so first off, a sketch. This is going to be a difficult sketch because a lot's going on. So it's quintic, so that means it must go from positive to negative or negative to positive. I'm going to do a big sketch here because this is going to be important, I think. So quintic has double root on 0, double root on 1, double root on 2. Oh, it's not even a quintic. Oh no, it's a single root on 2. Okay, phew. Double root on 0, double root on 1, single root on 2. Is that right? Quintic would, yep, that's right. Cool, so that's that. And g of x equals, so this is a quartic, but it is a negative quartic, so it's starting off in a similar manner. And it's got roots on, q and r are positive, so it's got roots on q and r, which I do not know. So q could be there and r could be there. And these are again double roots. So it's going to look like that. And what do I want to do? I want to maximize the number of real distinct solutions. So I think how I've drawn it maximizes that, right? I don't think I could get more than that. Because there can never be a solution here. This can be the last solution, so 1, 2, 3, 4. I think you want q less than 1 and r in between 1 and 2. I think if r was out here, there's a chance you could miss solutions. You could go like that. So yeah, I think B. I'm going to go with B. 19. Circle C1 is defined as x squared plus y squared equals 25. I'm going to give a bit of sketch. So that's a circle radius 5. Second circle C2 has radius 4 and centre AB, where minus 2 less than or equal to A less than or equal to 2, and minus 3 less than or equal to B less than 3. If the centre of C2 is equally likely to be located anywhere within the given range, what is the probability that C2 intersects C1? Okay, so this is 5, this is minus 5. Now the centre has to be minus 2 to 2 and minus 3 to 3. So it has to be somewhere in this region, which means that, isn't it always going to intersect? There, if that's the centre, it's definitely going to intersect. Oh, but if it's at the centre, it won't. So we need the distance from the centre to any point to be 4. Oh, so that's just another circle. Circle of radius 1. Anywhere on that, and then it just touches. Okay. So then it's just probability, right? What is the probability that C2 intersects C1? So if it's anywhere in the outside region, it intersects C1. If it's in the inner green bit, it doesn't intersect C1. Okay. So I just need to calculate those two areas. It's 2 minus 2, it's 3 minus 3. So the area of the red, the total square is 3 by 2 is 6. And the area of the green is pi r squared, which is just 1. Oh, that doesn't look right. Oh, yeah, my bad. The area of the red of the whole square is 6 by 4, because it's, yeah, double that. It should be 24. That equals pi. And so the area of the red bit is 24 minus pi. Out of the total area, which is 24, so divide that by 24. And is that an option? They say it's an option. F. Nice. 20. Okay. Last one, then we need to go back and fix all the other ones. N is the number of points of intersection of the graph. At y equals modulus of x squared minus a squared, and y equals a squared mod x minus 1. Okay. What's the smallest number of n that isn't? N is the number of points of intersection of the graph of those two graphs. What is the smallest value of n that is not possible? Okay, so what's the maximum number of solutions is what I've gathered from that. So first off, again, draw it. With these number of intersections ones, it's always best to just draw it. So y equals modulus, so y equals x squared minus a squared would look like this. We've got a modulus, so it's, I assume it is positive. Doesn't really matter, does it? Looks like this. And then x minus 1 modulus is going to look like okay, so just drawing it, this red line is always going to beat the green line because it's a squared versus a non-squared. So 4 is definitely possible. I've got that they're all possible. Oh, maybe it's, oh, so 5 is possible, but maybe a lower number isn't possible. Is 3 possible? 5 is possible because if I get it to just touch the top, that's possible. 3 possible. I don't know if 3 is possible. Can I get it to do something like that? So I'm thinking something like that would make it not possible. So what would that be? That would be just touching the top. So that would be, what are these solutions? This is A, and this is A squared. When x equals 0, yeah, it's A squared, A squared. And for the green line, what would the green line have to be at x equals A? No, that's not possible, I don't think. I don't think 3 is possible. Is there any other way to get 3? Is that possible? Does that have to be A? X equals A and x equals minus A. On the red line is definitely A. But on the green line, if it just touches A squared, then it's going to come down a lot closer. it's going to come down at... Oh, but if I pick a certain value of a, it doesn't really matter, does it? A equals 1 gives me that. Right? A equals 1, and plug in... Well, x equals a, because I need a... I need... Oh no, a equals 1 works. Yeah, a equals 1 works because at x equals 1, that one equals... the green one equals 0, and the red one, x equals 1 equals 0. Okay, that's fine. So that one works, so I can get 3. 3 is good, 4 is good. 5 I haven't checked, but if I can't do the others, then it must be 5. So 2. Is there any way to get 2? The only way I can think of getting 2 is by like bouncing it. Oh no, if I go high enough, like that, then it's doable. But for what value of a would I need that? So it needs to come down much quicker than it would. So a would need to be really big, but this blue value is always a, right? Oh no, it's a squared. X equals 0. So they always touch at a equals 0. I did not realise that until just now. Okay, they always touch at a equals 0. So... Oh, can I get 4? A equals 0. Do they have to touch at a equals 0? They do. They have to touch at a equals 0. How do I get 4? Well, so I can't get 4. It's got to be an even... It's got to be an odd number. So I can't get 4 and I can't get 2. Because of symmetry. I've got that one at 0, and by symmetry I have to have the other ones. So it's 2. Unless I can't get 1. Is there any way I wouldn't be able to get 1? N equals 1. Is there any way I can get 1? I don't even know if I could get 1. Let's have a look. It's all values of a. They have to cross. It has to touch x equals 0. It has to touch the y-axis. Sorry, the x-axis. Interesting. I'm not sure. Because could I get a equals 1? Is there any way I could get a equals 1? They have to touch there. I'm not sure. My guess is 2. But I'm not sure. I could get 1. Right, so now we need to go back to the start. Didn't finish 9. 9 was the first one. Okay, let's go back to 9. I feel like 9A actually could have a go at. So let's maybe just test them. It might be worthwhile. Just test the different values for 9. So let's go for 9 again. Let's start again. But I don't know what the minimum value is. Can I work out what f is? It's not easy to work out what f is. I was thinking it might be like f is 1 minus sine x and g is 1 plus sine x. Oh wait, that's fine, right? Oh wait, so if f of x, it's the other way around, but 1 plus sine x and g of x equals 1 minus sine x. Oh, no, there's pairs of functions. There's multiple different pairs of functions, never mind. I know it's at least 0. f of x equals, so it's minus b, so it's 2 sine x plus or minus the square root of b squared, which is 4 sine squared x, minus 4 times 1 times by sine squared x minus 1. All over 2. It's equal to sine x plus or minus the square root of, divide everything by 4, sine squared x, 2 ahead of myself, 2 sine squared x minus sine squared x plus 1, which is equal to sine x plus or minus 1, which is what we saw previously. When I was looking here, I ended up getting f of x equals 1 plus sine x or 1 minus sine x, and then g of x is 1 minus sine x. I just didn't see the other result. So what do we actually have here? What were they actually asking for in the question? They're asking what is the minimum value that f of x attains at any point. Well, we can see here that it goes sine x plus or minus 1, and the minimum of this is clearly minus 2 because sine goes between 1 and minus 1, and the minus 1 gives us the lowest. But yeah. Okay, I'm going to take a quick break and then I'll come back and mark it and see what I got wrong. Okay, so I'm back. It is a very hot day today and it got very, very warm in here. Had to take a little bit of a break, but now we're back and we're going to have a look through and mark it. So I've already been through this and I've had a quick look at all the ones I got wrong. I got 14 wrong because I forgot to go back to it, and I got 17 wrong. So we're just going to go over a little look through at what the solutions did and what I didn't do. Now 14 I actually forgot to go back to, if I'm honest. In the rush to try and get it done and all the heat, I missed it. Okay, so we got close with 14, but what we should have drawn is, we knew that this was 120, so I'm going to draw P and Q now horizontal, so just imagine spinning it round. It's P and Q, and then we know this is 120 degrees, this is 6, and we want to find where R is. Now, think about this like triangles. We want to find the maximum area of this. So the base is horizontal, right? So the equation, the area of a triangle is a half base times height. Well, at the minute, the height is fixed. That's where P and Q are, we can't move them. But we want to move R to maximize this area. Well, to maximize the area, we want it to be as far away as possible. And to do that, it has to go right through the center. That's how we make it as far away as possible. So in fact, this line isn't quite drawn correctly. Instead, we want it to look more like, if I get rid of this, we want it to look more like this. And then all we need to do now is calculate this length here, and then we can use a base times height once we've also calculated PQ as well. So PQ, again, because we've split it through the middle, this is 60 degrees and then this is 60 degrees. So to find the sides, we need to use, so to find this shorter one, it's 6 cos 60, then this is 6, and then this other length is 6 sine 60, which is 3 root 3, and then this one's 3 root 3. So our half base times height gives us a half times 6 root 3 times by 3 plus 6 gives us 9. And that ends up being 27 root 3, which if I look at the options again, oh yeah, that's D. And that is the solution. Okay, and finally is 17. I got so close on this one and I'm really annoyed I didn't get the ending bit. So we worked out that we have this equation for sine theta. Now, to be a bit more accurate, is we go on to the next page, we go sine theta equals a half 5 minus x. And then we want to consider what our values of theta can be. Well, realistically, we can have theta between 0 less than x less than 150. Can't go beyond 150 because we need theta between 0 and 150, and we can't go beyond 150 because all the angles must add up to 180 degrees. However, in order for us to get the two different results, if, say, sine theta equaled 0, we wouldn't get two non-congruent triangles. We'd only get one non-congruent triangle. So, in fact, this is our range. So we need sine theta to be greater than sine 30, not greater than equal to, just greater than, and we need it to be less than sine 150, which would be the same as, well, we need sine theta to be in that range, but it has to be less than 1. So we need sine 30 is a half, so we need a half less than a half, 5 minus x less than 1. Double everything, 1 must be less than 5 minus x must be less than 2. Okay, I'll treat these two separately. So I will do 2 plus x must be greater than 5, x must be greater than 3. And on the other side, 1 must be less than 5 minus x must be less than 4, so we've got 3 less than x less than 4, which is option D. So it was all about that 30 degrees, that's why we got the first bit wrong. Okay, then that is it. So I would have scored 17 out of 20, which I believe is either a high 8 or maybe 9, which is a good score. But yeah, some sloppy mistakes there that I could have fixed, but it's some hard questions and it's also a rushed exam. You're going to be messy. The whole kind of exam for me was quite messy. I was rushing about, trying to do everything and speak at the same time. But yeah, I hope you found that useful. It is a messy kind of explanation to these, but it's just a glimpse into how you should be attempting these exams. It's quick. You want to be quick with your maths. If you're not sure how to do it, move on to the next question. You can always come back at the end. Yeah, and it doesn't matter how you write, just want to be quick. Yeah, I hope you enjoyed this video. I'm going to be doing a part 2 on this, which is on the logic side, which is a bit more different, a bit harder. You can also take it a bit slower, so it'll be a bit more organised. But yeah, if you want to see that, please subscribe, and I'll see you in the next one.